Highlight for everybody this opportunity to explore one of the first global data sets that's out there, estimating forest canopy height. And I bring this up because this is one of the questions I have is where are the actual trees around the world? And we can see from this data set that was put together from the laser system that was put up in space back in the 2000 time period, that actually was the beginning for what is now the ISAT-2 satellite that's up there. And so because of this instrument, it didn't actually collect the same type of data as the current ISAT-2 satellite. But it really does give us a first glimpse at some national estimates of tree height. And so I want to highlight this because this is a good place where you might be able to go explore and see what was created during that kind of first initial phase of data collection between 2004 and 2008. And with this, what I want to highlight is this is what scientists do with their data afterwards. And so after this project was completed, similar to our researchers who presented today, NASA asks you to actually put your data and make it accessible to other people. And so there are these what's known as distributed active archive centers, or also DAC. And when you go explore a DAC, you can actually find a lot of historical data sets and other research data sets that might help give you context for what you're seeing today. And so in this case, you can actually go down and you can read the particular paper that was used to create this data set, the way that they actually calculated estimates of tree height, and as well as the spatial coverage. So I encourage you to go explore how you actually document the data sets once you have created and finished a project similar to what our speakers did today. I really want to highlight that, in fact, there are two data sets that are available to you. One is a shapefile, which is a format that allows you to actually map this data and put it onto a geographic information system that allows you to do some other analysis, make maps, and that kind of thing. But there's also, importantly, a comma-separated file that allows you to actually, explore the attribute data without using a map. And as a result of that, you can go in and you can explore, the country of interest and find out how much forest area is in that country based off of a particular land cover methodology that we mentioned here. And importantly, how much hectares is available in relation to the ISAT measurements that were made. And so this is one way of starting to evaluate and understand and answer the question, what country around the world has the tallest trees and which country around the world has the shortest trees or may not have any trees whatsoever. And so you can actually go and explore this data set on your own, and I really encourage you to do that. And I'll highlight that earlier, to bring this back to where we started hearing from Dr. Sean Healy, who is describing Mount St. Helens and the recovery that he measured there. This is actually a data set that he also put together as part of the carbon monitoring system that NASA and the Forest Service run together in conjunction to understand the world that's out there. So I just wanted to highlight this as a way of looking back between 2004 and 2008 and to understand the forest height that's out there. And the interesting thing is now we have ISAT-2 up there that's collecting data in a very similar fashion. And this allows us to do a comparison contrast. But importantly, I would like all of the researchers out there to consider and think about what type of information would we like to have in 10 years from now, right? What is the important part about the data that we need? How do we actually describe this in such a way that you can actually go back to these locations and do a comparison and see how have trees grown and how have they been impacted by the last 10 years of decisions? So we will provide this link out with this, and I'll do a little bit more data description about what I'm seeing in this data set. But I would really like people who are on this call and others who are interested to share with us what you find in this data set. Where is the tallest trees in the world based off of this initial estimation of global tree height? Share with us what you're finding and whether that's appropriate for or what you understand about your particular area. So with that, I will end my brief introduction to a really interesting and unique data set that was a predecessor to ISAT-2 data that you can find in the Open Altimetry website. So good luck on your data spelunking and comparison between this particular data set and the tree height estimates that you're finding in your area.
All right, thank you, Peter. Anybody have any questions for Peter?
Hey, Peter, this is Christopher. So because the lasers on ISAT versus ISAT-2 are so different in their sampling, for those of you that aren't quite as familiar, ISAT, the original mission, had a very large footprint, much more widely spaced than ISAT-2 does, which, because it's a photon counting instrument instead of a waveform collecting instrument, basically gets photon times back from each profile versus the broadly diffused waveforms from the original ISAT mission. So do you have any thoughts on how well those two different measurement techniques will play together, I guess?
Yeah, I think that there will be differences. You would expect to see some differences between that. And I would also anticipate to see some differences between those two different instruments in the way that they're measuring or trying to estimate that height of the structure of the trees in this case. But also the difference between what we're measuring on the ground and how we're measuring it. And for me, I think this is a really key piece of science. Right? How do we know what we're actually measuring is we're getting the right numbers, right? And depending on the instrument that you use, the size of the instrument that and what you're measuring might change over time. And so this is where this full documentation about the data set that you're using, the instruments that the instruments that you use to make those measurements, and importantly, the errors around that. What's the smallest thing you can measure? Millimeters or centimeters or meters? And what are the limitations? And the sample or the amount of data you could get back from this original LiDAR system was a lot less than what we're getting today. And so we would anticipate some differences between that. I'll also point out one of the big areas that you might find differences is in 10 years of tree growth. Every single tree that was measured by this particular LiDAR has grown. And the question is, how much has that grown, and how do you bring in that 10 years of growth into the differences in the instruments, as well as the actual making sure you're measuring the same exact tree, right? So this is, again, where that data documentation and maybe journaling, other pieces of information that can help scientists 10 years from now is a very important part of this process, because we expect instruments will get better. We'll be able to locate those trees a little bit better, but yet things will change. That tree may no longer be there in 10 years, or the trees that were measured by this instrument may no longer be there, right? So there's a lot of challenges as we start looking back into the past, and we have to start thinking about the instruments, the phenomena that we're actually measuring. And so that's where the only way to really know the differences or the challenges is to start investigating. So I do hope that people will take this data set and maybe compare it to the Open Altimetry website and see what they actually have. So that's a great research question, Chris. I really appreciate you bringing up the difference between the instruments and how that might affect our measurement.
I see a slightly different version of this in the tropical glaciers that I'm watching fade away, in that for many of them, the 30-meter pixels of the thematic mapper were fine back in the 80s and 90s. And as you get into the 2000s and the 2010s, the ice masses have shrunk so much that 30-meter pixels are actually too coarse to really get a good sense of how the ice has changed. Anna pointed this out to me on the local volcanoes across up the Chilean border area, where they actually have some pretty good documentation going back many, many decades, and as these ice masses have just shrunken away. And Landsat 10 is currently being designed and is likely to be substantially different than Landsat 9 that has yet to be launched. So this is the progress of technology and the commitment of resources to make things compatible with, but better in the long run.